post that on Google if you need, or YouTube, whatever. If you need that, just pin myself there. So yesterday, I posted in the Google Classroom. I was just missing a set radius command, and that's why my ball didn't show up. So I'm going to share my screen. Share Z. And there I am. And what we were missing was one line of code. And it was in our ball class here. It was this line. I forgot to put it. And then, so what would happen is by default when you make a circle shape, and that's what the ball is inheriting all that stuff, it just automatically sets its radius to 0, its origin to 0, 0, and its, let me just move this over to, its origin to 0, 0, and its color to white, and all that stuff. And that's what happened when I ran this. It was putting the positions of the screen, so I knew it was like moving around in my Box 2D world. I just couldn't figure out at the time that I forgot to set the radius to R, so when you do that, it should, well, it's going to crash because I forgot a semicolon. But there it is there. Okay, so ball bouncing. There is a platform in here somewhere, it's just not showing up. If the ball hits it, it will bounce off of it. We're kind of, basically, we've gotten rid of our reliance on the physics.h file. We are using world.step and using this b2 world. And that's basically all Box2D is doing for us. It is just keeping track of any little body we place in this world. We don't really have to do much other than like for instance, when I did body, when I made my ball here, I just go body equals world.createBody and body create fixture, and that's enough. That's all Box2D does. It does everything behind the scenes for us with this world.step. So we don't really have to worry too much about Box2D anymore. We're just kind of going to worry about the little objects we've made. And if you notice, our main is really small now too. It's not as cluttered. I don't really have much here. I have ball P1 set up, update position. I guess I'll put my paddle.update position in there too. Why not? And then I don't need to put anything there. So let's get this paddle to draw as well. Okay, so what we'll do is we'll go to our paddle code. We'll get rid of this line here. We don't need, like, this was a way that I was using in physics to like draw SFML shapes using display world, but we don't need that anymore. Set origin to the middle of the paddle. I wonder if that sets it to the middle. Maybe it does, maybe it doesn't. We might have to deal with that. Let's find out later. But if you remember, you just write the word this now. Okay? Whatever the person names their paddle, when they make it, you want to set the origin once and the position once and the color once. I'm going to change it later. You don't need this command either. That was another command a complicated command that allowed me to draw everything using physics display world, so that you didn't even have to use window.draw. Those days are over. Okay. So if I run this, the paddle will just be stuck in place. Right now the paddle doesn't draw at all, and that's because I didn't draw it. Window.draw P1. So now it should run. Oh, it still doesn't show it. Weird. Did I forget to set a size to the thing? Probably. This dot set size? Yeah. Vector. That's the other thing we're missing. I guess we're missing our radius and our size for our paddle. So we will set its width. And height. So that's the one thing we're missing in the paddle code. This dot set. Let's see if that shows up on the screen. There's my little paddle. Okay. The problem is I can move it, right? Look at that, I'm moving the paddle perfectly over my ball. But it doesn't actually update its position when I do that. And that's because I have to put some sort of code in here to say update your where you are with regards to where you are in the box2D world. So the way I did it with the ball code is I had these 3 lines of code. So I'm going to copy them. Basically it says take whatever position you get from the box2D body and set it, and take whatever rotation you get from the box2D body and set it, and then draw it. So I'll put it here somewhere, or just at the top. Maybe leave myself a little message like getting data from box to the body or something like that. And then the other thing you have to do is make sure you're passing it a render window. I call it render. I also put an ampersand sign in front of it so that it will allow you to change your window. If you don't, it will crash because it will try to change your window, and you can't do that unless you put an ampersand sign in front of there. Okay. And then the last little detail I have to add is that when I call my update position command now, I type in the word window. See, like, making your own little objects can get really complicated. There we go. Okay. We're back to square one now. We got a paddle and a ball. All that code just to get these 2 little guys bouncing around the screen, eh? There we go. But we have detached ourselves from physics.h. The only time we ever use anything in there is right here. We make our walls. And we basically made our own 2 little entities here that kind of borrow some SFML and borrow some box2D, but they're our own little people now. We can do whatever we want with them. We can add some more functionality to them later if we want. I think today the one thing we'll do is we started with this check collision function yesterday for the ball, and the whole point of that was to bounce the ball some other way. Okay? To bounce it off the paddle in not a random way, but like in a way that you can control the ball more instead of it just bouncing off the paddle at the angle it came in. Because then your brick breaker game will be really boring. You'll have no way to steer the ball a little bit. So let's figure that out. How are we going to do that? We're definitely going to do it in the ball code. We could do it in the paddle too. It doesn't matter. I just think it's better that the paddle's kind of simple and the ball is going to be the more complicated entity. Plus, it's the it's the ball that's actually changing its angle, right? So it's best if we're inside that code when we go to do that. So what did I add to this paddle code to change it? These are all the word this now. I also added a set size, and then I pasted these in as well. Into my update position. Here.
Oh.
Pencil's under the chair. Yeah. Alright, let's do this. Let's do this. Should we do it in here? Why not? I guess we could do it in our update position command. Let's do it. Bouncing. We could do it in our check collision command too. But maybe someone will just want to check collision and not have the ball bouncing every time they want to do that. I don't know. It doesn't really matter where we put it. So let's put it inside of our update position. Bouncing ball off paddle. Alright. I did draw a little picture of this yesterday too. I still have that. One note. Yeah. There's my awesome picture. I'm going to try to find the position of the paddle versus the position of the ball. So if it's like 50 to the left of the center or 50 to the right and it's hitting, then I'll pick some sort of angle to bounce it off at. And if it's 0, I want it to go straight up, and anywhere in between I kind of want it to go off at an angle, kind of like a spread of an angle like that. You can see my mouse cursor. So I think the first thing we'll probably do is just output their differences in their position when we hit. So I'm going to go you know what, I'm actually going to have to put this in my paddle, my check collision function, because I need to reference the paddle that it's hitting, and this function has that because if you can see, I'm passing it the paddle. So I guess I'll do it right before I return true. Okay. And that way, if it is hitting, it'll do all my code and bounce my ball, and then afterwards it will return true. If I put it anywhere else, it won't work, because this is the spot in the code where it's detecting that it's hitting. Okay, so I'm going to say, now, I'm going to say P1, or I want my ball's position, but I don't know what the person has called the ball in the code, right? I have to go back and use this word, this. So I'm going to say this dot get position dot x. I only care about the x position. And then I want to subtract the paddle's position. So P1 dot get position. They're both SFML objects as well, so we inherited all that stuff. So let's just print that out for now and see what kind of numbers we get. See like if our origin is right or anything like that. So let's run that. Where's my error? Oh, when I use this, I have to use an arrow for this one? I wonder why. Oh, it's because this is actually a memory address, so it wants an arrow for that. Let's see. Hey. Oh, I know why it's not doing anything. It will work, I'm sure, but I need to be able, I have to call check collision in my code, right? I haven't done that, so I have to go here, and I have to go B1. I lost my auto type for some reason. Makes me sad. If that ever happens, you can right click in your project here and just go reparse this project. Usually that fixes it.
I do.
B1. There we go. Check collision. And it's looking for a paddle. And I happen to have a paddle called B1. Okay, so that should now make sure that this code is running every frame. Where is it? Right, let's see what it spits out for us. I'm going to hit it on the left edge here and see what number we get. I got minus 35. I think that's kind of good that it's minus. If I hit it on the right edge, I get 41. And if I hit it in the center, hopefully I get 0. Ooh, that was 13. Minus 6. So yeah, that's close to 0, I think. And it's good that it's minus. If I hit the right edge, it looks like 50 and 50. That makes sense because my paddle's 100 wide, right? I made it 100 wide. So it was 70 there, but yeah, it looks like my picture here is good, actually, that this is minus 50 and this is plus 50. So if I can just take that number and then times it by some sort of angle, I wonder if that will work. I want this to be 90, right? Let's say I want this angle to be 90 and I want this angle to actually be, makes sense. Yeah, 0 is up and alright, let's try to set our angle then of our ball. Go for it, good. Alright, let's do it. How are we going to do this? We need to take our ball's body. Okay. You can see all the box 2D commands you can do. I used to put them all in the physics.h under different names, but you could start maybe looking through some of them and seeing which ones you might want to use. I'm going to do set linear velocity, and it looks like it just wants a 2D number. Box 2D has its own built-in 2D number. It's fine. Like I could do something like this. It says it wants a B2 vec2. Sure, I'll just write B2 vec2. Just the same way I would write it as vector 2f and SFML. They mean the same thing. And let's say I go 10 and 10. These are going to be probably really big numbers or something. I don't know what they'll be yet, but let's run it and see what happens. It's going to like make our ball when it hits the paddle do something wonky. Yeah, it moved it down, I think, into the paddles. Let's try minus 10. I think it just bounced it kind of at 45 degrees no matter which way it hit. Yeah, you can see that. I guess that makes sense because 10 and 10 is like 45 degrees. If you think about it as like a triangle that's got an X and a Y at 10. Alright, so let's come up with some numbers, or maybe what we do is we just get we do an angle or something like that, right? Let's say I do 10 times the cos of some angle, and then 10 times the sine of some angle. That's how you get stuff to move in the angle you want it to. If you remember, I don't think I had a picture here, maybe I did. Yeah, there's my old picture, right? If I know a speed that I want to go and an angle I want to go, I have to give it the x coordinate s times cosine of the angle, and I have to give it a y coordinate of sine of the angle times s. So if I could just come up with an angle with my math based on like something based on that, should be okay. For now, I'm just gonna write like I'm just gonna write the number 1 because I think it's in radians. Yeah, it's trying to force it down again, so maybe I'll make that a minus 10. I don't really know what this angle is going to be, but it looks like it's like 60 degrees or something. Always bounces off at that angle now. But if I can change that angle based on how far the thing is away from the center, based on this number, then that will be a good thing to do. So why don't we make an angle variable inside of here. Float angle. Do I already have angle? Yeah, I do. I don't want to redo that. Actually, I can use angle. I've already made it, so, and I only used it once. So I don't even have to make it. I can just write angle equals, and then I gotta figure out some way to incorporate these numbers. Copy, paste, like that. You know what I might do? I might, so if I go back to what I've done here, I'm getting numbers between minus 50 and 50, right? So, but I really want this to be 90, right? Let me get my different color pen. I want this one to be 90, let's say. And let's say I'm happy with this one being 50 degrees this way, right? But what angle is that in SFML? This is actually going to be minus 90 because this is plus 90 in box 2D and SFML. And this is like, this would be minus 50 because it's backwards from the origin. Remember that that's my axis there, down is up and down. So this is minus 50, and then this would be like minus 140, right? So I have the numbers minus 50 to 50, but I want them to go from minus 50 to minus 90 to minus 140. So how do I do that? It's not that hard to do. It looks like if I just subtract 90 degrees off of these numbers, 0, 50, and minus 50, I'll get the right angles I want. So let me try that. I'm going to just write minus 90 here. And that is going to be in degrees. But cosine and sine need radians, so I'll just write angle divided by degrees per radian. Don't I have that command? Divided by degrees per radian? Sure. Right. angle divided by degrees per radian. Let's cross our fingers. Let's see if that works. Maybe we don't need the minus 10 anymore. See that? I've already taken care of that with the minus 90 there. So I'm not going to put that minus 10 there, and hopefully that will, because I just saw that the ball was forcing its way into the paddle again. I don't want that. Okay, so far so good. That looks good. What if I hit it in the center? Will it go straight up? Hey, here you go. It actually worked. I am shocked. Ooh. It's gonna be a little bit flawed depending on how wide your paddle is. If your paddle's too wide, then it'll try to like bounce it underneath or something. So, I mean, in the future we may want to, and maybe it doesn't bounce as sharply as we'd like if it hits the side, right? Maybe 50 is not enough. Like, I guess what we could do is kind of take this number and just times it by some sort of factor, and then divide it by itself. Is that what we want to do? Here's like a foolproof way to make sure that it works for every paddle, right? Because right now it's really dependent on our paddle being 100 pixels wide, because 50 just worked out to be a nice angle, and this 50 did as well. But I think probably optimally, if we take that difference, divide it by 50, and then times it by some sort of factor, it'll work for any kind of paddle. So let's say I want to times it by a factor of, right now it was working fine. This should actually be paddle width, right? So if my paddle was like 200 wide, then I put 200 there, and still times it by 50, or maybe I'll times it by like 70. I want it to bounce more. So I'm just kind of coming up with a fudge factor that makes it a little bit more sharply bouncing. Let's see if that works. Yeah, it bounces a little more sharply now on the edges, which I like. Whoa. But now you can actually steer the ball, which is nice. It makes for a much more interesting breaker game for sure. And if I hit the center, it goes straight up, and that way you can kind of pick out the last few bricks and get going. We'll add bricks tomorrow. It's today Wednesday. So there you go. You got some good bounciness there. Bounces really sharply off the edges. If I was going to make my paddle wider, so I'm going to get rid of this code for a second, okay? And just keep it the way we had it. But I'm going to make my paddle much wider. So when I go to make my paddle, I set the width here to 100, right? Now I'm going to make it 300. You'll see what happens. See how glitchy it is? And it has to do with the fact that, let's see here, where is that code? It has to do with the fact that now my paddle is going to be minus 150 and minus 150 here. So that's going to mess up my angles a lot. So what I'll do is I'm going to divide this by 300, or maybe even 150, half the length of the paddle, right? And then I could times it by the 70 number that I liked the way it bounced the last time. And now it should bounce properly. Yeah, here we go. So if you ever have a power up in your program, and your paddle gets wider or shorter, then you're not going to mess up your bounciness. There you go. Cool, right? So I think that's the way for us to go. Boom. And maybe we could even change this. Instead of saying 150, we could say this dot, or this arrow get size. Is there a get size command? Oh no, it's p1 dot get size. Right? It's all about the paddle's size. p1 dot get size dot x divided by 2. We want half the paddles. Man, that's a crazy function. I wonder if that will screw up with bed mass. Let's check it out. Probably. Yeah. Bed mass got us. We have to put it in brackets. It's getting really intense, isn't it? We divide by that and we times by 70. Yeah, let's try. There we go. Looks good. You hand that in, your game's done. This is fun, isn't it? We should make a timer, see who can play the longest without dying with this paddle and this ball. There we go. So that's good. I like these numbers. I think they work for me. Happy with them. If I go to change my ball's width back to, or my paddle back to 100, it should bounce nicely. Just trying to kind of catch bugs before they happen. Right, because you could down the line maybe make a power up where your paddle changes its size and all of a sudden your bouncy code will be all screwed up and you're like, what the heck's going on? It'll be very hard to find out why. Right? So as your program gets busier and busier, it's harder to tell. That's why I leave myself little messages as well. Right? Bouncing ball off paddle. Why not? That way I can find that code. Okay.